Not too long ago, the New Horizons space probe got up close and personal with everyone's favorite, the ex-planet Pluto. Before we talk about why it isn't a planet anymore, we need to know what a planet is. In our solar system, we have a total of 8 known planets. In order of distance from the Sun, they are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These planets are categorized into terrestrial, gas, and ice giants. Let's start off with the 4 closest planets to the Sun: Mercury, Venus, Earth, and Mars. These are categorized as terrestrial planets, also known as telluric or rocky planets, meaning Earth-like. These planets are mostly made of rocky materials. They have a metallic core, primarily made of iron, and a silicate or rocky mantle. Being made out of rocks, these planets are generally dense. Earth is the densest planet in the solar system, followed by Mercury, Venus, and Mars. Due to their density, the rocky planets tend to be closer to their star. As we continue outward from Mars, we get to our next category, the giant planets. Jupiter, Saturn, Uranus, and Neptune make up the well-known giant planets in our solar system. A giant planet is just a massive planet. We have 2 subcategories in the giant planets: the gas giants and the ice giants. These are different based on their internal structures. Gas giants, such as Jupiter and Saturn, are mainly composed of hydrogen and helium. These are sometimes known as failed stars. They have the exact same composition as a star, but are nowhere near as massive. They couldn't get big enough to light the fuse and become a star. These planets have a thick hydrogen gas atmosphere surrounding a layer of liquid metallic hydrogen. The pressure on the hydrogen is so immense that it becomes shiny and conductive, gaining the properties of a metal. Ice giants, such as Uranus and Neptune, are mainly composed of elements such as oxygen, carbon, nitrogen, and sulfur. These are heavier than the elements composing the gas giants. Don't be fooled by the name ice giants. These ices are not just H2O ice, they are methane and ammonia ices as well. Ice giants have a layer of gases such as hydrogen, helium, and methane surrounding a layer of water, ammonia, and methane ice. These atmospheres are much thinner than the ones of the gas giants. All the giant planets in our solar system share many properties, which is why they weren't made into separate groups until the 1990s, when enough of their internal structures was known to warrant the switch. Jupiter, Saturn, Uranus, and Neptune are all extremely massive, but not very dense. Jupiter is the second most massive thing in the solar system, behind the Sun, having a radius about 11 times that of the Earth. But it is so big that it is not very dense. Saturn being the least dense, so much so that if I had a large enough bathtub full of water, it would float on it. Since the giant planets are not as dense, they are further away from the Sun than the rocky planets. So now that we've gone over the categories of the 8 known planets in our solar system, let's talk about another classification: non-planets, more specifically dwarf planets. Until a formal definition of a planet was made in 2006, Pluto was the 9th planet in our solar system. After that, it was known as a dwarf planet, as it remains today. The formal definition of planets is that first, they must be orbiting a star, second, they must have enough mass to compress into a spherical shape, and last but not least, they must have cleared the area around its orbit. Any large body that does not meet these criteria are classified as dwarf planets. Pluto meets the first 2 criteria, but not the last one, due to its size not being big enough to cause other objects in its orbit to either join itself or leave its orbit. You might ask why they would make such a weirdly specific specification in order to be a planet. Well, it's because we found way too many. In 2005, a dwarf planet named Eris was discovered, and it is 27% heavier than Pluto. An object in the asteroid belt named Ceres is a spherical object that contains about 1/3 the mass of the entire asteroid belt. Others, like Makemake and Haumea, are confirmed dwarf planets, and there are about 200 other dwarf planets just in our solar system. If we count Pluto as a planet, then what about the countless others? We'd rather only have to remember 8 planets, but not Pluto, than to have to remember 200 planets for our 6th grade science class. Today we learned about the terrestrial planets, the gas giants, the ice giants, the dwarf planets, and where our beloved planets belong.